We're going to go ahead and assume that v1 bar and v2 bar are two linearly independent vectors. And with this information, we're going to create two brand new vectors, u1 and u2, and we need to show that those u1 and u2 are linearly independent. So by definition, what does it mean for v1 bar and v2 bar to be linearly independent? Well, we know we run straight to the linear combination formula. So we know the linear combination of v1 and v2, so c1 v1, c2 v2 equal to the 0 vector. If we solve that out, because they're linearly independent, we know that the only solution is the trivial solution. So we get to assume that. We know that if we ever find a constant times v1 plus a constant times v2 equal to the 0 vector, those two constants have to be equal to 0. Let's now ask the question, are u1 and u2 linearly independent? So how do we do that? Well, we consider the equation where we take u1 and u2 as a linear combination. So let's do a u1 bar plus b u2 bar. We take them as a linear combination and set it equal to the 0 vector. So now we have to solve this equation for a and b, and if we find that there are non-trivial a and b that make this true, linearly dependent. But if we can show that the only solution of this is a equal to b equal to 0, linearly independent. So let's see what we can do. Well, what do we know about u1 and u2? Well, we know what they look like in terms of the v's. So let's go ahead and do that. So just plug in. We know u1 bar is really v bar plus v2 bar. And we know u2 bar is just v1 bar minus v2 bar. And since we're working with this equation up here, that's all equal to the 0 vector. Well, let's collect terms here. What do we have? We have, when we distribute that a in, we have a v1 plus b v1. So let's go ahead and collect these things here. Distribute the a in, distribute the b in. So what's the coefficient sitting in front of the v1? Well, it's a plus b in front of the v1. And similarly, when we distribute in, we have an a v2 minus b v2 floating around. So that's a coefficient of a minus b v2 floating around. But what do we know about the v1 and v2? We know that they're linearly independent. So if we ever find ourselves with a constant times v1 plus a constant times v2 equal to 0 bar, we know that those constants have to be 0. So since v1 bar and v2 bar are linearly independent, what must be true? Well, those constants up here in yellow must be 0. So we know a plus b must equal 0 and a minus b must equal 0. So let's now solve this for a and b. So this second equation, I mean, this is real straightforward. The second equation says a must equal b. Now take that and put it into the first equation. We'll get 2a has to equal 0. So a has to equal 0, which then forces b to equal 0. So what have we done? We have looked at the equation that decides whether things are linearly independent or not. A constant u1 bar plus a constant u2 bar equal to 0 bar, and we've shown that the only solution is the trivial solution. Therefore, by definition, u1 bar and u2 bar are linearly independent.